Hello everyone, and welcome to my channel. We do educational videos on this channel. We try to shed light on things that you may not have ever heard of before, but if you did, you'd be glad you did. And today is our 404th video on the reciprocal system of theory from one Dewey Bernard Larson. Mr. Larson was a mining engineer, I believe, in the 20th century, lived out west, Portland area. And around 1959, he proposed his two fundamental postulates, which were a distilled version of his overall theory of how the universe operated. And then through a process of deduction, he went from his fundamental postulates to a theoretical universe about, okay, if my postulates are correct, my two fundamental postulates, if those are correct, then it would lead to a universe that looks like this. I documented Larson's chain of deduction in my 15 videos that I did about a year ago called The Outline of the Deductive Development of the Reciprocal System. So if you go back to those, you can see his chain of reasoning. And then from his theoretical universe, in his books, he compares the findings of the legacy scientists, what they measured in their laboratories, their observatories, and through other empirical means, and compiled in their tables. He compared his theoretical universe with the so-called actual universe of the legacy scientists. And those kind of comparisons are what kind of drew me to Larson, because he was able to, in many cases, recreate scientific tables strictly from theory, not requiring billion-dollar grants and armies of teams of scientists, chipping away at it over the course of centuries. But instead, it was just one guy with no budget and a slide rule that was able to put these tables together. It's not like there was absolutely no disagreement, but the majority of the findings were really the same or identical to a lot of the findings of legacy science. So Larson's two fundamental postulates kind of started all off publicly, although it took him about 25 years to come up with those through a process of induction, where he started having his first inklings way back around 1930, and it took him forever to kind of take all of those different findings and put them into a generalized situation. And but his two fundamental postulates kind of provide an introduction for the reciprocal system of theory. The first postulate is, the meal ticket does most of the work. And the second postulate is primarily mathematical. The first postulate states that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with two reciprocal aspects, space and time. And then the second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, the second postulate is more controversial, especially among some of Larson's followers. Many of them reject the idea of Euclidean geometry as being the geometry of the universe, not rejecting it outright, but saying that Euclidean geometry is the geometry of certain subsets of the universe, certain situations in the universe, but it is not controlling in all situations, and that we would be better off substituting projective geometry for Euclidean geometry, as projective geometry contains Euclidean geometry, but it is more inclusive. The same is true of the commutative mathematics in that second postulate. But let's talk about the first postulate, maybe just restating it. The universe is not made out of matter. It's not made out of energy or anything else except that it is made out of motion. In particular, it is made out of a obscure kind of motion that Larson calls scalar motion. And a scalar motion is a motion that has a magnitude, but it has no specific direction. So it is a much more general kind of motion, non-localized. There's no direction to scalar motion. You would envision a scalar motion using a balloon that has dots on it. As you blow up the balloon, all of the dots will be moving away from each other. But they will not be moving in any specific direction. Every dot will be moving away from every other dot. But you wouldn't be able to apply a direction to that movement. Really, you would apply all directions to that movement. And you wouldn't be able to apply a specific direction until you declared one of the dots as the reference point. Once you say, okay, this particular dot is the reference point, meaning that we are going to arbitrarily decide that this particular dot is motionless, and then we can measure the directions from that dot to the other dots. But that is basically stopping the universe, or freezing the universe, so that we can make a measurement. The direction is not part of the motion itself. It is part of the reference system that you've assigned. And by holding one of the dots still, then you're able to make those measurements. Okay, so the universe is composed of motion, in particular this kind of motion that's called scalar motion. And motion is the relationship between space and time. And that sets up a generalized reciprocal relationship between space and time. Space and time are reciprocals of each other, which means that they are identical to each other, except that they are in reverse order. They do not exist in and of themselves, only existing together in motion. Motion is basically a fraction where time or space is the numerator and space or time is the denominator. And as a much more generalized kind of motion, all of our scientific quantities fit into the purview of scalar motion. So all of our scientific quantities are motions, which includes matter and energy and force. These are all relationships between space and time. Matter is time to the third power over space to the third power. Energy is time over space. Force is time over space to the second power. As you know, speed is space over time. The car is moving 15 miles per hour. 15 miles of space in 1 hour of time, space over time. Acceleration, space over time to the second power. The ball fell out the window at 32 feet per second. 32 feet of space in 1 second per second. Space over time to the second power. One thing that Larson observed about space is that it is multidimensional. He called it three-dimensional. X, Y, Z coordinates, or volume. 3 orthogonal dimensions in a still frame. This is what Larson refers to as coordinate space. And since space and time are reciprocals of one another, we also have something that's called coordinate time. And this is three-dimensional time in a still frame. And then also we have so those two are vectorial motions, and they are, meaning they have direction. And they are the result of really stopping the universe. But if we allow the universe to continue in motion, then we deal with the scalar aspects of those. Larson refers to those as clock time and clock space. The clock is always getting later and later and later and later, but it is not getting later in any specific direction. And space is always getting farther and farther and farther apart, just like on the surface of an expanding balloon, but not moving in any specific direction. And then space and time also are only in discrete units. You have to have a full unit of space to have space. You have to have a full unit of time in order to have time. And if you have exactly 1 unit of space in 1 unit of time, you have what Larson refers to as unit speed. 1 over 1 equals 1. And this unit speed is also equal to the speed of light. So the speed of light is really 1. And as in all reciprocal systems, 1 is at the center. When you take any 2 reciprocals and you multiply them together, you get 1. And, so one of the reciprocals is on the positive end and the other one is on the negative end, and 1 is in the center. And that basically means that this speed of light, this 1, is the neutral point of Larson's universe. It is what he calls the null point, or the progression of the natural reference system, the ether, the origin. the background, the um, 0 point. These are all descriptions for moving outward at the speed of light in all directions. So if you have an entirely empty universe, you have nothing in your universe, you still have motion outward at the speed of light in all directions. That is the nature of a universe of motion, or of Larson's universe. So in order to really grasp Larson's universe, you have to be able to grasp the concept of motion without anything moving. The motion precedes the thing that's moving. And then ultimately, that thing that's moving is actually made out of motion also. That's another important caveat of the reciprocal system, is that normally throughout the many years of science, we've envisioned space and time as being really like the container of the universe. The actions of the universe are occurring in space and in time. The players of the drama of the universe are acting in a setting or in a environment of space and time. But in Larson's universe, space and time are the contents of the universe, not the container. They are the actors on the stage. And so that is another kind of a paradigm shift there. And so when you have the speed of light as the midpoint of the universe, that means that half of the universe is moving faster than the speed of light, half moving slower than the speed of light. Larson refers to these as the cosmic sector and the material sector. And really, the material sector is the only one that is known by legacy scientists. Einstein himself said that the speed of light is the maximum speed of the universe. So by saying that, he's really eliminating half of Larson's universe, the cosmic sector. But the scientists, if they ever acknowledge their mistake, would be able to catch up very quickly, because the operating laws of the cosmic sector are identical to those of the material sector, except that they are reciprocals of one another, so that you have to reverse the roles of space and time. So in the material sector, you have relationships based on coordinate space, 3 dimensions of stationary space, and clock time. The clock's always getting later and later and later. In the cosmic sector, once you cross that speed of light boundary and move into this faster than light realm, then you have relationships based on coordinate time, 3 dimensions of time in a still frame, and clock space. Space is always getting farther and farther and farther apart. So that shows that reciprocal relationship there. And Larson uses that reciprocal relation to great effect in his analysis of things. Today we are going to embark on a reading of one of Larson's great books. It's called Basic Properties of Matter. And here you will see how Larson takes his theoretical universe and he compares it to the periodic table, and also to compounds. And so he is able to, come up with equations to determine things like the melting point and the boiling point of different elements and different compounds. And then he compares those numbers to the tables that have already been derived, have been measured in the laboratories. And so this is a test for the reciprocal system, more or less, as well as a test for the legacy science system. So we're going to start. This book came out in 1987, when Larson was almost 90 years old, and just a few years before his death. And he clearly was thinking clearly at this time in his life, and I believe up until the end, was thinking quite clearly. And so we're gonna at least read the preface here of this book to start with. Okay, the preface. This volume is the second in a series in which I am undertaking to develop the consequences that necessarily follow if it is postulated that the physical universe is composed entirely of motion. The characteristics of the basic motion were defined in the book Nothing But Motion, the first volume of the series, in the form of 7 assumptions as to the nature and interrelation of space and time. Just for the record, we went over that book probably about 6 months ago. We didn't cover the entire book. I think we only covered the first 3/4 of it or so. We'll probably go back, and the last part of it is like on organic chemistry. The beginning of Nothing But Motion is mostly on atomic physics. And so we did go over that whole book, and so you can refer back to that. But that's about 6 months ago. So that book's called Nothing But Motion, and this one is Basic Properties of Matter. Okay, so the first volume of the series in the form of 7 assumptions as to the nature and interrelation of space and time. In the subsequent development, the necessary consequences of these assumptions have been derived by logical and mathematical processes without the introduction of any supplementary or subsidiary assumptions, and without introducing anything from experience. Coincidentally with this theoretical development, it has been shown that the conclusions thus reached are consistent with the relevant data from observation and experiment, wherever a comparison can be made. This justifies the assertion that, to the extent to which the development has been carried, the theoretical results constitute a true and accurate picture of the actual physical universe. In a theoretical development of this nature, starting from a postulate as to the fundamental nature of the universe, the first results of the deductive process necessarily take the form of conclusions of a basic character: the structure of matter, the nature of electromagnetic radiation, etc. Inasmuch as these are items that cannot be apprehended directly, it has been possible for previous investigators to formulate theories of an ad hoc nature in each individual field to fit the limited and mainly indirect information that is available. The best that a correct theory can do in any one of these individual areas is to arrive at results that also agree with the available empirical information. It is not possible, therefore, to grasp the full significance of the new development unless it is recognized that the new theoretical system, the reciprocal system as we call it, is one of general application, one that reaches all of its conclusions in all physical fields by deduction from the same set of basic premises. Experience has indicated that it is difficult for most individuals to get a broad enough view of the fundamentals of the many different branches of physical science for full appreciation of the unitary character of this new system. However, as the deductive development is continued, it gradually extends down into the more familiar areas where the empirical information is more readily available and less subject to arbitrary adjustment or interpretation to fit the prevailing theories. Thus, the farther the development of this new general physical theory is carried, the more evident its validity becomes. This is particularly true where, as in the subject matter treated in this present volume, the theoretical deductions provide both explanations and numerical values in areas where neither is available from conventional sources. Okay, just to kind of add to that point, I do find that, in order, the more you read Larson, the more valid it appears. When you start reading Larson, you're just kind of like, where's he getting this from? He's just kind of pulling this out of no place, and he's just fitting this into the discussion so that his data coincides with the data that's already been arrived at. But then you read another one of his books in an entirely different field, and he's using the same equation. And the same equation is coming up with answers in a different field. So it's not that he just pulled it out of no place. He actually derived it deductively, and maybe you got lost in the chain of deduction. But he's not just tailoring the equation for this specific set of circumstances, because he's using the equation in entirely different fields. But you never really detect that unless you have looked at a number of his different books. Okay. There has been an interval of 8 years between the publication of Volume 1 and the first complete edition of the second volume of the series. Inasmuch as the investigation whose results are here being reported is an ongoing activity, a great deal of new information has been accumulated in the meantime. Some of this extends or clarifies portions of the subject matter of this volume. Of the subject matter of the first volume. And since the new findings have been taken into account in dealing with the topics covered in this volume, it has been necessary to discuss the relevant aspects of these findings in this volume, even though some of them may seem out of place. If and when a revision of the first volume is undertaken, this material will be transferred to Volume 1. The first 11 chapters of this volume were published in the form of reproductions of the manuscript pages in 1980. Publication of the first complete edition has been made possible through the efforts of a group of members of the International Society of Unified Science, including Rainer Huck, who handled the financing, Phil Porter, who arranged for the printing, and Eden Muir, who prepared the illustrations, and Jan Sommer, who was in charge of the project. Dewey Larson, December 1987. Okay, and that brings us to Chapter 1. And Chapter 1 is called Solid Cohesion. Okay, so he's going to be talking about, how atoms stay together in the solid state. How they each separate atom clings to each other. And we will be delving into at least the beginning of that chapter starting tomorrow. In the meantime, thanks for tuning in today, and have a great day.